Hey class, so I will be doing 2 word problems from worksheet 2, the review for test. So I'm going to start with number 2 and then I'm going to do number 3. Number 2 says you need to make a rectangular box out of a piece of sheet metal that is 3 times as long as it is wide. Let's pause for a second. What that means is that the width is x. And the length is 3 times that, so the length is going to be 3x. Now, those are the original dimensions. And just to keep everything really organized, I am going to take note of that. So the original dimensions, the length is 3x and the width is just x. Okay, so again, I'm just taking note of the original dimensions of the metal sheet. Then it tells me that I cut out 4-inch squares out of each corner, and the resulting volume is 1,000, that was the bell, 1,036 cubic inches. So here's the deal. I'm cutting out these little squares. And these little squares are 4x4s. And when I cut those out, I'm eventually going to fold up these sides. And when I fold up these sides, I will be left with a box that has this as a length that I'm highlighting here in orange. So the length of the box is not 3x. It's going to be 3x, and I'm going to have to take away this 4 that I just highlighted and this 4 that I just highlighted. I'm going to have to take away 8. So that leaves just this highlighted part as the length of the box. So the length of the box is going to be the original 3x, but then minus 4 and 4, so minus 8. Likewise, the width of the actual box is going to be this yellow highlighted portion. So I'm going to take the x and I'm going to subtract out this 4 and this 4, okay, which is going to be subtracting out 8. So the width of the box is x minus 8. Okay, so let's go ahead and let's write down the box dimensions because they're different. So the box dimensions, the length is 3x minus 8. The width is x minus 8. And the height is always the height of those little squares. So the height in this case is going to be 4. So those are the box dimensions. Now, when I set up my algebraic equation, I'm going to use the box dimensions because ultimately I know the volume of the box. Volume of the box is 1,036. And that has to equal the box length times the box width times the box height. So I'm going to write that all out like this. I like to put the number first. So 4 and then 3x minus 8 and then x minus 8. This is the setup. I just have to get everything on the same side for the calculator setup. So what I personally like to do is divide over the 4 or whatever number this is. Usually the other side will be divisible by that number. So let's divide over the 4. 1,036 divided by 4 is 259. And then I'm going to FOIL out this resulting product of binomials. So 3x times x is 3x squared minus 24x minus 8x. So when I combine those, I get minus 32x, and then finally plus negative 8 times negative 8 is 64. Let's go ahead and move that 259 over to the other side by subtracting it. So I get 3x squared minus 32x. And let's see, 64 minus 259 is negative 195. Now, I could just type this into the calculator. Personally, I like to see, all right, I think all of these numbers are divisible by 3. So if I divide out the 3, I get an x squared. Oh, 32 is not divisible by 3. Whoopsies. Okay, that's okay. So we're actually done here. We are done. That was silly. I know 33 is divisible by 3, so I should have known, but that's okay. Okay, so that's my calculator setup, and now I'm literally just going to go into PolySimult in my apps. I'm going to go to PolySimult 2. I'm going to go to the Poly Root Finder, and I'm going to put in this information. So the coefficients are 3, negative 32, and negative 195. I'm going to hit solve, and it gives me my 2 answers. Just the calculator should just spit out those answers. So I get 15, and I get negative 13 over 3. Well, guess what? I can't have a negative length. So my answer is x equals 15. But let's go backtrack and see what the question's actually asking. It's asking what the original dimensions of the metal sheet are. The original dimensions are the 3x and the x. So I know that x is 15. So that's my first answer for width. And 3 times 15 is 45. So the dimensions of the metal sheet are 45 by 15. You could write 15 by 45. Doesn't matter which order you put it in. That's the answer. The next one is a little bit quicker. It says, suppose that the future population, P of T, of Stockton City, T years after January 1st, 2020, is described in thousands by this quadratic model. In what year will the population reach 180,000? All right, so I want to plug in 180 for the population. So that's 180 equals, this is kind of written weird. I don't know why they wrote it in this order. I'm going to rearrange it in the next step. Okay, I am going to subtract over 180 so that everything's on the same side. So on the left side, I have a 0. I'm going to reorder this. I'm really not sure why they wrote it backwards, but I'm going to reorder it to be 0.07 t squared plus 4t. 110 minus 180 is going to be that negative 70. And now I'm just going to, that's my calculator setup. And I'm just going to plug it in to PolySimult 2 in my calculator. So again, I'm going to go into Poly Root Finder, and I'm going to type in my coefficients. So 0.07 for the x squared, and positive 4, and then negative 70. Okay, so I got t equals, there's 2 answers. One of the answers is negative 71, which obviously time, we're going to throw that one out. So the correct answer is about 14.05, and that's years. Now, the question is asking in what year? So we're talking about starting with 2020, okay? And this is going to be 14 years after 2020. So 2020 plus about 14 or 14.05 years is going to be the year 2034. So that's the final answer. Where will you guys be in 2034? Well, you'll be like almost my age, 30. Actually, I'm 31. All right, that's it for the our word problem video. So hopefully this makes sense and helps you out a lot.